You've just seen me walk across red hot coals at a temperature of over 500 degrees Celsius. I could tell you that I'm an expert in an ancient form of meditation that lets me block out pain at will. I could then tell you that you could lead a happier life if you follow my teachings, for a small fee of course. Or I could tell you the truth, that walking on hot coals doesn't require any kind of magical powers. It's just the case that the coals are a poor conductor of heat, and I walk so quickly that there's hardly any time for heat transfer to take place. Separating truth from fraudulent mumbo-jumbo is just one reason why science is important. Hello, in case you haven't guessed, I'm a science teacher here at Camden School for Girls, and this is 7R. Say hello, girls.
Hello!
Now, it might look like they're just messing about making bubbles, but in fact, they're doing a very serious investigation. Eleanor, why don't you tell these nice people what you're doing?
We're using 3 different types of washing up liquid to see which one will make a working bubble solution with the least amount.
Good, and how are you doing that?
I'm going to use the same amount of water to make it a fair test, and then each time I will add 2 millilitres of washing up liquid and then stir it and see if it works.
Excellent. It's really good, Eleanor, thanks. Now, clearly, Eleanor here is an expert with the scientific method, but sadly not all students believe that science really matters. And just like all teachers, science teachers are often faced with that inevitable question.
What's the point of this?
Now, if you're even thinking of becoming a teacher, that's a question that you really should have an answer for.
Why is science important?
It's quite a difficult question, I suppose.
It's quite a hard question.
What a question. Why is science important?
It's a question that you should ask yourself.
Science is important because it's everywhere. It's one of those fundamental subjects that creeps into everyday life
Because it informs every single thing we do.
Important issues like global warming and MRSA and obesity.
I don't think it's necessarily a question that people ask themselves very often.
I think that students deserve a really decent answer to this question. And as a science teacher, you'd expect me to have an evidence-based approach to finding one. So a few months ago, I started this website in which I asked other teachers, scientists, writers, and members of the public to give me their answers. I've been overwhelmed by both the number of people who took the time to contribute and the quality and variety of their responses.
Well, I think it's important because we live in a scientific age, and it's important that society understand the science.
Knowing how the world really works and finding out by looking at the world is better than just believing what someone tells you or just making up a fancy about it.
Well, I think it's the way of arriving at truth about the universe because, taken in its most general sense, science is disciplined inquiry.
I'll be coming back to some of these answers later on in the film, but I thought I'd start by examining one answer that has come up repeatedly, that science is important because it's built the technological world we live in.
We live in an immensely complex world, increasing amounts of technology from iPods to spacecraft and so on. But the challenges we face are technological too. Look at global warming, look at MMR vaccine, look at bird flu, look at the energy problems, the energy crisis we're running into. All these things are technological problems that need scientific and technological solutions.
Given these types of responses, I thought I'd take a closer look at the link between science and technology.
Stand by 3.2G, 15 seconds.
This might look like I'm here just to have fun, but in fact, it's a scientific test facility that spins pilots around, subjecting them to the kind of forces they'd experience in high-speed flight.
I'm loving it, I'm loving it.
Various scientific instruments measure and record the physiological effects of these forces allowing scientists to test and develop technologies for supersonic aircraft.
Does this mean I can be a fighter pilot? Because I can take this all day.
Thanks for that, Des. I felt completely safe in your hands.
It's really good.
Now, you're one of many scientists here. I was just wondering if you could talk to me a little about how you think science is important for developing technology.
Well, I think that science is all about establishing the true nature of the world around us, and we can only do that by making measurements that are valid, collecting that data in a rigorous way, analysing it in an appropriate way, and then we can make small changes to try to establish cause and effect, which is ultimately how we go about developing new technologies. We're here at Farnborough, which has always been at the centre of aviation evolution since the beginning of the last century. Aviation development was very much by trial and error in the early days, and of course that was very hazardous potentially for the pilots who could end up wrapped around a tree or crashing into the ground. Nowadays we couldn't possibly develop a new aircraft in that way. We have to use science and facts, data that have been collected over many years to show that the technology is going to work.
Stand by, 5G.
It's a lot more uncomfortable. My arm weighs a ton and feeling quite horrid now.
The sky is not the limit for these scientists. I also spoke to rocket scientist Alain Greenie to ask how they're developing technologies with the potential to push us even further.
This is a test chamber that we're using to test rocket engines. What we're doing here is building engines which are going to take a spacecraft to the planet Mercury. Basically, the first few years of the programme were about developing the fundamental science behind how the rocket would work, and that draws on a huge body of knowledge of plasma physics and material science to design an engine which would work in this sort of environment, which would be able to travel to other planets. What we're doing now is we're testing it in this test chamber, which allows us to see whether it will survive in the space environment. If we're serious about really travelling to other worlds and doing proper science and exploring, then we need new and innovative technologies like this to get us there.
I've had a really interesting time here at Kinetic, where the connection between science and technology is abundantly clear. Now, in the past, technological developments could happen by trial and error, but today, the scientific method is absolutely crucial to developing new technologies. It's our deep scientific understanding of the world that lets us develop everything from super high-tech jet planes to safer transport to life-saving drugs. So at first glance, technology seems like a good answer to the question, why is science important? But not everyone who contributed to the website was so convinced.
I'd like to respond to those who say that the importance of science lies in technology. I think that point of view simplifies both disciplines. Both science and technology come packaged with a whole variety of moral, ethical, and indeed practical decisions and principles. I think we in the West need to stand back and ask ourselves, do we need more MP3 players when in fact people in poorer countries don't have access to clean drinking water? Similarly, do our military need ever more fighter aircraft when in fact people in poor countries are unable to access the internet? I think it's important to stand back, to look at science and technology, and to see what benefits they bring to the world, and to question whether the answer to the question, why is science important, lies in technology.
Technology can improve the quality of our lives, but it can also lead to weapons of mass destruction. Now, arguably, science is morally neutral when it comes to technology, and it's up to us how we decide to use it. Whilst technology is an important outcome of science, I think we need to look deeper to find a more satisfying answer to the question, why is science important? So what else have people been saying on the website? Well, one answer that really leapt out at me was Robin Bell's, who said that science is crucial to the long-term survival of our species. Now, if that was true, I think we'd have a really good answer to the question. Drilling deep beneath the surface of Antarctica, scientists from the British Antarctic Survey are using ice cores to understand how our climate is changing. Bubbles of air trapped hundreds of meters down give them clues to what our atmosphere was like up to 800,000 years ago. I went to meet ice core drilling engineer Jack Trist to find out exactly what this kind of research has taught us.
There's two key things that we've learned. First of all, the Earth's climate has been changing for the last 800,000 years, and sometimes it's changed very rapidly. Secondly, we know that human industrial activity has really contributed to, for example, greenhouse gases. The level of greenhouse gases that we see currently has never seen before in the last 800,000 years. If the climate was to change very rapidly, we need to be ready to act. So that's why we really want to know what contributes to climate change and how quickly it can happen.
One of the reasons why we face climate change is our reliance on fossil fuels. But these scientists at the Jet Fusion Lab are working on something that could change that. They're trying to recreate the process that keeps the sun shining. Nuclear fusion. This research could one day provide us with a clean, virtually limitless source of energy.
Achieving that goal of having an energy source for the future, a clean and safe and abundant energy source for future generations. That for me is the main thing. We have demonstrated that we can produce energy with fusion in this reactor here. We wouldn't be able to build a fusion power plant straight away because that's far too complex. You have to split it up in small problems which you then tackle and then organize experiments to solve each individual problem. And that's what these people are doing here. Today they have to find a problem they want to solve. They solve it, they hope, and then we move on to the next one. And all these small steps will lead to the solution of having fusion as a working power plant. With science you can make a change. With science you can actually change the future. You can make the world better.
The scientists at JET are convinced that nuclear fusion is going to play a big role in our battle against climate change. It wouldn't be the first time that science has solved a crisis of our own making. This might look like a fairly boring lump of metal, but in a very real sense, this machine helped to save the world. It's called a Dobson ozone spectrophotometer, and about 25 years ago, scientists from the British Antarctic Survey used this and others like it to discover a hole in the ozone layer. The scientific evidence also pointed to a man-made cause: ozone-destroying chemicals like CFCs found in aerosols, refrigerators and air conditioning systems. Following the scientists' discovery, governments around the world came to a historic agreement to phase out the production of these ozone-depleting chemicals. Today, the hole in the ozone layer is no longer growing, and there's a good chance that one day it will permanently repair itself. Now, science didn't save the world on its own, but it was science that allowed us to uncover the threat in the first place, and it was science that came up with a solution. There's no doubt in my mind that the science being done by the British Antarctic Survey and the Jet Fusion Lab is important. Now, there's no guarantee that science will solve all our environmental problems, but it is our best hope. For me, though, it's not the fact that science might save the world that's impressive. It's the fact that it's science that lets us know there's a problem in the first place. I think it's amazing that we can confidently describe what the atmosphere was like hundreds of thousands of years ago, and that we can understand and perhaps exploit the process that fuels the stars. This kind of deep knowledge of how things work is only available to us through science, and that's why it's important. Another reason many people gave for why science is important is its role in helping humanity in a different way, through medicine.
It was scientists who really worked out and realised in the 19th century that germs cause infectious diseases. Before the germ theory, there was no scientific basis for sanitation and hygiene, for example, separating drinking water from sewage. In the 20th century, it was scientific observation that led to the eventual development of antibiotics. Unlike polio and smallpox, we don't yet have a vaccine against HIV. That's what my lab is working on at the moment, amongst many others, but it's a much tougher nut to crack, probably because we don't understand enough about the science of HIV infection and how it infects the body. But science must pervade medicine all the way through.
This is one of the most important locations in the history of science, the Sanger Institute near Cambridge. It was here that the Human Genome Project was largely completed, and today it's at the forefront of cutting-edge medical research. I met with Gillian Dalgleish who studies the DNA of cancer cells.
I think it's really important to have an evidence-based medical research approach to the development of new treatments for cancer. We have to start off with a hypothesis and test that through experimentation and build on our previous knowledge and that of others. Science research is based on peer review, which means if you come up with an idea and you test that idea, then other scientists can say whether they agree or disagree, and hopefully through that process we can come up with really effective, safe treatments. And also to just give a basic understanding of what cancer is and how we can tackle it best.
There can be little doubt that science has transformed our world for its practical impact on technology and medicine, nor that it may one day solve our environmental problems. However, we mustn't get carried away and start to think of science as a panacea for all the world's ills. It's really only through politics that the fruits of science can change our world. Therefore, lots of people who contributed to the website argued that it's vital that politicians and the people who vote for them understand the science upon which they base their decisions. As Martin Robbins said, effective democracy depends on it. In today's world, it's increasingly important for scientists to communicate their work to the rest of us. One person whose job it is to raise the public understanding of science is Marcus de Sortoy. So tell me all about this new job of yours.
Well, I'm the new Simoni Professor for the Public Understanding of Science here in Oxford. And I kind of see it as an ambassadorial role for science, trying to tell people why science is so exciting.
And why is it an important job?
Well, I think it's important because we live in a scientific age, and it's important that society understand the science. And we live in a democracy. It's important that they make informed decisions. And unless the scientific community actually tell them about the science, they're not going to be able to make those decisions. So that's why it's really important.
What kind of approach are you going to take?
Well, I think that's really difficult because actually society is many different things. Key audience, of course, are kids because they're going to be the next scientists. They're going to be answering the problems that I can't solve. Then you've got the geeks like me and the people who love science and they want more. So it's very important for scientists to tell them what's happening in the news. But I think a really important audience are those that are totally turned off by science, don't see what the point is at all. They often are a major part of society, big part of our democracy. And then there's government. And government's really important because they're deciding the funding for science and they're making the big decisions about climate change or stem cell research, what should we do? So if they don't understand the science, we're in a bad way.
Marcus has got a really important job to do, but arguably every science teacher has an even more important job because people's understanding and appreciation of science usually begins and often ends in the classroom. So are we taking the right approach to convincing young people that science really is important? Many teachers I spoke to expressed concerns about the way science is taught in our schools. David Perks was one of them.
The way we address science in the classroom these days, and in the modern sense of it, sees the point of science as addressing the individual as a consumer of science rather than as a producer, a future scientist. And that's sort of addresses the idea of making it accessible and relevant to young people. But to my way of thinking, that completely misses the point about what's distinct about science. And science is one of the last vestiges of the curriculum where you learn a formal academic subject, which gives you the capacity to then go beyond your knowledge and address issues that you wouldn't otherwise have a grounding in.
Although the curriculum plays an integral part in the way we teach science, it's not necessarily the most important part, as Mick Waters explained.
The curriculum can only go so far. We know teachers all across the country who have grabbed at the curriculum, made it work for them, not seen it as an anchor but seen it as a springboard where there's no telling what they could do given the opportunity. Problems occur when people think the curriculum has to fill every moment of every lesson, when the syllabus has to take over. And the challenge is to say, come on, we believe in ourselves as science teachers. We can teach children science. And I know it's hard because over the years we've been more and more accountable. Schools have accountability thrust upon them. Departments have to deliver results to contribute to the school's results. And we start to look at our children as currency in terms of GCSEs or A-levels, rather than little learners, little scientists, little investigators of the future. Actually, where we teach real science to children in a scientific way, with enthusiasm and rigour, we'll get the results.
There's lots of debate about the best way to deliver science education. However, I think it's important not just that we teach children science, but we let them know why it's important and how a scientific outlook can help enrich their lives. Take a look at this clip from Becky Parker.
Science is important because if we don't quest to understand our universe and the amazing things in it, then we're not carrying on the traditions of our forefathers and trying to develop our scientific understanding. We're not looking at the possibilities of what the future may hold, and we're not grasping this amazing fact that we can understand something about the universe and about our brains and ourselves and the smallest bits of matter and the biggest bits in the universe. And if we don't do that, then we're not really the sorts of people that surely we want to be as a human race. We want to understand.
Becky's a science teacher I really admire, and I think she's right. I think the reason why science is important is because without it, we're not really fulfilling our potential as human beings. And she was by no means the only person who expressed this idea. For example, astronomer Seth Shostak said, "Science can gift us with more than just a Dolce Vita. It can transform an accident of evolution on a small rocky world into a significant fact of the universe." I think these kind of answers are getting closer to the reasons why I think science is important. The basic desire to answer the so-called big questions is a major driving force in science. And nowhere is this perhaps clearer than in astronomy. So Francisca, thanks very much for inviting me along here. It's really impressive. But there are people who think that equipment like this is frankly a waste of money and that, staring at the stars is a waste of time. What would you say to those people?
Yes, I understand that, because apparently looking at the stars is pointless because, the stars are so far away, so what? What's the point of looking at them? Astronomy puts us in contact with the grand scale of the universe, both in space and in time. Only astronomy can bring us to the knowledge of our place in the universe. Not that we have it yet, but we are getting there. What is our origin? What is our destiny? Without the stars, there wouldn't be chemical elements in the universe. And that's what astronomy has told us. That's part of our origin, our makeup as stardust. And just to know that is a very satisfactory thing to have in your life as part of your culture. Whether you are a scientist or an accountant or a doctor, doesn't matter what you are, taxi driver, doesn't matter what you are. Just to know for sure what the chemical element is and where is that chemical element coming from makes you feel something very special, like belonging to the universe. And yes, if you become a scientist and you become part of that process of discovery, is even more satisfactory, as it is in my case.
Lots of people agreed that just knowing about how the world works, about our place in the universe, is why science is important. I spoke to A.C. Grayling, as I hoped a philosopher could explain exactly what was so special about science as a method for obtaining knowledge.
Well, I think it's the way of arriving at truth about the universe because, taken in its most general sense, science is disciplined inquiry. So it's the kind of inquiry which formulates its questions very carefully, which tests them, and it does so in a way which is public and repeatable, which submits itself to review by other people, challenge, and which is very open-minded. It's prepared to accept that it may not arrive at answers, but that if it does arrive at answers, that those answers might generate new questions, but it's prepared to put up with those. Something very special about the scientific mindset, which is that it is prepared to live with open-endedness.
Another person who's really passionate about the scientific method is psychologist Sue Blackmore. She responded with the intriguing line, "Truth is better than illusion." I went to meet Sue and found that she's got a really personal reason why science is important to her. Your career in science started rather oddly, if I may say so, with investigating the paranormal. Does that relate to your belief that truth is better than illusion?
I had, like many people, I had extraordinary experiences when I was at university mostly, which led me to believe in telepathy, clairvoyance. I had an out-of-the-body experience, which led me to believe that my spirit had left my body. And I was convinced by all the occult explanations that people gave me. But I've always been of an inquisitive mind, even since I was a child. And I wanted to know for sure. And I set out to do the experiments. And of course, what happened was I found out that I was wrong and I had to change my mind.
But Sue, what does it feel like to have your whole world view turned inside out?
It was kind of frightening and a bit depressing. But I think knowing how the world really works and finding out by looking at the world is better than just believing what someone tells you or just making up a fancy about it.
As a science teacher, what I really want for my students is that if they go away with anything, and it doesn't have to be A grades at GCSE or A level, it should be the ability to question things.
To think for themselves.
To think for themselves, absolutely.
Mm.
I'm incredibly grateful to everyone who's contributed to the website and to this film. Reading and listening to their answers has really helped me to clarify and confirm my own ideas about why science is important. So I guess all that remains is for me to give you my answer. This is one of my favourite places, the Natural History Museum in London. It's been described as a cathedral to science, and in my opinion, it's a fitting title. The Victorians believed that public access to the knowledge within these walls would make us better people, and I have to agree. Growing up, science was really important to me because it gave me this whole new way of looking at the world. Unlike other adults, my science teachers didn't just present me with truths about the universe. Instead, they taught me about a method through which reliable, testable knowledge could be arrived at. And that's what I want for my students, for them to see that science isn't just a collection of facts and figures, but rather a remarkable way of thinking. More than that, I want them to be able to fully appreciate just what an amazing accomplishment the body of scientific knowledge is. That science is an ongoing human endeavour, perhaps the greatest of human endeavours, and one to which they might one day contribute. Now, I don't mean to be cheesy, but I really think that without science, my students will be handicapped in their ability to be all they can be. Because I think that science can help us fulfill our potential as individuals and as a species. Science lets us see superstition for the disempowering nonsense that it is. I think it's the only method that can truly satisfy our innate curiosity, and it literally lets us reach for the stars. That's why science is important.